Hello, welcome back to lesson 6.2, part 3. So these last examples, there's about 6 pages, are just some extra items. So it says the golf scores for a school team were normally distributed with a mean of 68 and a standard deviation of 3. Find the probability that a randomly selected golfer scored less than 65. Which is less than the mean. So here is the mean at 68, and we want to find the probability that he scored less than 65. Okay. So we're going to go into Desmos, and we're going to use the min at a negative infinity and the max at 65. And this is the probability that X is less than 65. And here we are on this one. I'm going to just hit my magnifying glass. So here we are, less than 65. And it looks like that is 0.1587. So about 15.87%. Then the next one says, find the probability that a golfer scored between 66 and 70. So I have that one here. And look at, we have 2 clear boundaries. You can see the purple shaded area on the graph, 66 and 70. And that likelihood is 0.4950. So about 50%, the middle 50%. And you can see my paper for that. That's 66 and 70. So and that's about 0.4950. And the last one says, what score would a golfer need to be in the top 15%? So top 15% means we want to look at the top score here where the right-hand area is 0.15. So X of 0.15. So we're saying that probably that X is greater than something, and that area is equal to 0.15. So we're going to have to use our inverse CDF here and of our normal distribution. And then we're going to type in 1 minus 0.15, because remember that it has to be the left area. So we have to do 1 minus the right-hand area. So let me show you that. And that is this bottom row right here. And it looks like that golfer would have to score a 71.11 to be in the top 15%. $71.11. Okay, we're going to look at number 10, example number 10. Is like in the US, the ages, in the US, the ages 13 to 55 plus of smartphone users approximately follow a normal distribution with approximate mean and standard deviation of 36.9 years and 13.9 years respectively. Determine the probability that a randomly selected smartphone user is between 23 and 64.7 years old. So let's go ahead and draw what this looks like. So the mean is at 36.9. And we want to look at the probability between 23, so that's going to be over here, and 64.7. Not necessarily equal symmetrically, but it's in between there. So that will look like this. 23, X and 64.7. Okay, so okay, so let's share my screen here so you can see this. And I'm going to hit my magnifying glass. So that's what we're looking at, between 23 and 64.7. And it looks like that area is about 0.8186. So about 82% likelihood. B says find the 30th percentile. So to find the 30th percentile, we are looking for the outcome that is 30% is below that. So that's definitely less than half. So 30% maybe is over here somewhere. So 0.30. And we're looking for the X that matches that. So that's a left-hand shaded. So a probability of X less than, and we got to figure out what X value where the area is 0.30. Now, when we put that in Desmos, let me take you there. Not on the graph, it's this bottom one here. We have to use the inverse CDF because we know the area is 0.3 and we have a mean of 36.9 and standard deviation of 13.9. And we're talking about the left area, so that's 29.6. So the golfer would have to have a score. I'm sorry, this is not golfing anymore. This is the years of the smartphone users. So they're an age of, so it looks like 30% of smartphone users are less than 29.6 years old. 70% are older. I'm not sure what year this was. Let's look at the next one. It says, what is the probability that the age of a randomly selected smartphone user is less than 27? That's going to be over here. So less than 27, this one up here was 29. So I'm guessing it's a little less than 30%. So what is it? Probably the X is less than 27 years old. And that means our minimum is going to be a negative infinity and our maximum will be 27. And that looks like about 23.8. So 0.2382. So about 23.82% of cell phone users, smartphone users are less than 27 years old. Let's look at example 11. Example 11 says 2,000 students took an exam. Scores in the exam have an approximate normal distribution with a mean of 81 and a standard deviation of 15. Calculate the first and third quartiles. Scores for the exam. What does this tell you? So the first and third quartile. So we have to think back a little bit, back to chapter 2. First and third quartiles. So this would be Q1, Q3, or the 25th percentile. So the Q1 is the same as the 25th percentile. And Q3 3 is the 75th percentile. So we're talking 0.25 is one of them. That's going to be the Q1. And then the Q3 is going to be 0.75. And that's all the way shaded over here. So this one is going to be the probability that X is less than something equal to 0.25. And then this one is a probability that X is less than something equal to 0.75. So we're using inverse norm, the inverse CDF for the normal distribution. So the Q1, the 25th percentile, is going to be a score of 91.1. No, I'm sorry, 70, I misspoke. It's a 70.8. 70.88, because we're talking about the 25% here. Now the 75% is going to be higher than the mean, and that one's going to be 91.1. I misspoke. So 70.88 for the 25th percentile, and the third quartile will be 91.11. B says 60% of the students earned at least what score on the exam? So at least is going to be a greater than. What score did at least 60%? And 60% is pretty high. So it's bigger than 1/2. So that means that this is 0.6, this space here. And I'm going to show you that on the screen here. And because I'm looking for 60% to the right, I am putting in 1 minus 60. And so that is a score of 77.2. We'll round that too. So 60% of students scored higher than a 77.2. Okay, let's look at example 12. So example 12 is talking about a citrus farmer. A citrus farmer who grows mandarin oranges finds that the diameters of mandarin oranges harvested on his farm follow a normal distribution with a mean diameter of 5.85 and a standard deviation of 0.24. Says find the probability that a randomly selected mandarin orange from this farm has a diameter larger than 6. Okay, so the mean is 5.85, and we want to find the probability of having a diameter bigger than 6, so greater than the mean. And what would that likelihood be? So I'm going to share my screen with you all so you can see. And it is this normal distribution here. Let me hit this is it. There's the mean at 5.85, and there's the probability of being greater than 6. And it is 0.2660. And the next one says, the middle 40% of mandarin oranges from this farm are between what and what? So the middle 40% means that I've got symmetric here, so play along with me. 0.4. So this is in the middle, 40%. So we've got a lower boundary diameter and an upper boundary diameter. And now because this is a specific context, it's not symmetric, right? This diameter is going to be smaller than the mean of 15.8 of 5.85. And this one is going to be a larger diameter. So we've got x1 is equal to probably the x is greater than, x1 is greater than, I'm sorry, that one's less than something. And that has to be this outside area. So we've got 0.4 here. So that means we've got 0.6 divided by 2 or 0.3 on either side. So this one is less than an area of 0.3. Let's go back and find that. Oh, here. So we have an inverse norm. And okay. So our mean and standard deviation are in, and we want to be 0.3, 30 to the left. So 30% to the left. So that diameter is going to be 5.724 centimeters because it's smaller than the mean. And then I want to show you the other one, x2. This one's bigger than the mean. And it's greater than something, but we can't do, so we've got 30 to the right. So we want to know it's greater than, is that 30% here. So we're going to do 1 minus 30. So it's over on this side, or you can do 0.7. It's up to you. So I will show you. I'm typing. So I'm just going to go in here and do 1 minus 0.3. And that will give us a diameter of 5.976 or 5.98. So this x1 is 5.724 and this x2 is 5.98. And then the last example is find the 16th percentile and interpret it in a complete sentence. So 16% is going to be to the left because half is 50%. So that's 0.16. And we want to find what diameter of the mandarin oranges, where 60% are shorter or smaller in diameter. So this is probably the x is less than some x equal to 0.16. And so I'm going to put in just as it is, 0.16. And so that diameter is 5.61. So this says 16% of mandarin oranges from this farmer, right? This is just the data from this particular farmer, are 5.61 centimeters in diameter or smaller. So catch me back for the next lesson part from chapter 6.